I saw you submitted everything last night.
Yeah, I just didn't do the
Paper.
Yeah, the paper.
Okay.
Yeah.
You look good on the camera.
I think I do. Should we go see if Dr. Leap is here and wants to see this? Can I? Or no?
Yeah, he's here, but he said he's gonna have an exam,
Oh, okay.
so he will probably join over Zoom.
Okay.
But
Gotcha.
you can try.
Okay. Yeah, he said he's gonna be over in like a minute or two.
Okay, he's gonna join from his room or?
No, he's gonna walk in.
Oh, okay. Then I think I need to bring this up to the projector.
Oh, can you not see my? Yeah, you can not see.
Oops. Also, turn off the speaker. We're gonna update this room with a big screen next semester.
A bigger screen.
Not a projector, but a TV.
Oh,
It
yeah?
has a 80 diagonal, like,
Really?
yeah.
Right where this is?
Yeah, on top of this. So this will be removed.
Yeah.
I think it's better for the clearance and, I mean, for clarity and also, you know, the bulb is very easy to age. So,
Yeah.
yeah,
Sweet.
it's better.
All right. Is it gonna be all in person next semester?
I don't know yet. We have to watch closely.
Oh, yeah?
Yeah, maybe. I mean, if everyone got vaccinated. Did you get your vaccination?
Yeah, I just had my second shot yesterday.
Oh, how was that?
It was terrible. I was like sick all night yesterday. And I could barely sleep, but I feel better now.
I was the same.
Yeah?
Like, especially the second day. So I got a shot in the afternoon,
Yeah.
but the whole night I was fine, but the second morning I was totally running a fever.
Yeah.
Yeah, it's very bad.
Yeah.
I'm the audience? Yes. Welcome.
Oh, my.
All right. Am I ready?
Okay, let me. Ooh, can I hear myself?
Yeah. Do you want me to mute mine?
I just want to make a brief introduction to you and the presentation.
Wait, should I mute myself or no?
I think you can turn off the speaker for a moment. Okay, that's nice. Okay, welcome everyone. Today we're gonna have the CS400 projects in computing presentation by Brock Culver. And his work is going to be on the college admissions. He has done amazing job in this software development and system development. So we can't wait for your presentation today.
Thank you, Dr. Li. I appreciate it.
Maybe you can now on your speaker and also turn up the volume if you want.
Okay. Yeah, so my name is Brock and my advisor was Dr. Li, and my project is about college admissions. So let's get into some background first on college admissions. You can see that the percentage of high school graduates immediately enrolled in colleges in 2019, 66.2%. That number's been trending upwards since about 1950. And this is about 2.3 million students aged 18 to 24. And then another 200,000 students over the age of 24 attending a post-secondary institution for the first time each year. So it's a huge number of students going to college every year. And according to this source here, National Association for College Admission Counseling, 36% of first-time freshmen applied to 7 or more colleges in the fall of 2015. So you can already see just 7 times this 2 million. You're going to be in the tens of millions of applications to colleges every single year. So this presents a problem. So what is the problem? The college institutions, they're trying to fulfill their maximum capable enrollment while maintaining the desired academic records. They also want to maintain a desired level of diversity, a desired participation in ongoing clubs. This is important because schools do not want their clubs to die, especially with the case of sports, because then that makes students less likely to come in the future. So maintaining the amount of clubs in sports and also attempting to grow it is usually a goal. You want a variety of learning styles, and then you also want a continuance of all the academic programs. You don't want to be admitting a class that has no business students, whereas the year before had like 100 business students. So you've got a whole lot of variables going into this application that the college enterprises want to solve. And it's a difficult problem. So how do they solve it? Well, we've got 3 general solutions here, just to get an idea. Approach 1, you take the high school diploma and your application, and that's the only requirements to entry. This is a lot of the times the case with community colleges. So it's a pretty common approach. Just anyone who applies and has a high school diploma is admitted in. Approach 2, there's minimum thresholds for SAT and GPA, as well as a necessary application. And then if you meet those qualifications, you're automatically entered. This is the case with state schools a lot of the times. Even E-Town, I think, has like some SAT threshold, and then you don't have to pay an admission fee. So that's sort of like a similar approach there. And that's those first 2 are a lot less complicated because they're just threshold meet and then admit. And then in that second approach, those below the cutoff, they're reviewed, handled case by case. That's the involving of a person or an employee, college admissions counselor. And then case 3, this is the most advanced, most difficult approach to college admissions. All the students are handled case by case. And this one's really difficult because the schools want to build a community with their students. And it can get really tricky if you have like hundreds of thousands of applications and you're trying to be selective. Each admissions counselor is only going to get one slice of the pie, and they can't really see the whole thing. So it's just a difficult problem all around. So how do I feel about this problem? I think you've got yourself some inputs to a college application. You've got the grades, essays, letter of recommendation, standardized test. And then you've got really a binary output, which is an admissions decision. So that's either yes, no, and occasionally there's wait list. But that sounds like inputs, outputs, sort of sounds like a computer science problem. And I think maybe we could do some automation here. So how does admissions think about automation right now? There's the potential for cost saving, increased efficiency, but overwhelmingly, admissions counselors do not like this automation idea. I listened to this podcast about Yale, and they were going over how they do admissions. Everyone wants to get into Yale, so it's difficult, but they said that they do not want to use some sort of automatic process. They're very humanizing in every application. They look over everything. They spend hours on every application. So they have a resistance to losing the job, resistance to dehumanization. But overall, it could be used as a supplement with the some sort of automation could be used as a supplement with the applications, and also the potential for cost saving and increased efficiency is pretty much never ignored by institutions. We'll skip this more abstract right now. So let's take a look at my project. So my project is a website. I chose that because they have the what I believe to be the easiest accessibility. It's pretty easy to get on a website. It's got a Firebase backend. That's because I had familiarity with Firebase in the past. All the code is on GitHub. And then we've got a Python automation of the database of students. So one of the first problems you run into whenever you're trying to admit students is who are the students? So I had to make up students and their essays. So that's the first component of the project that we're going to look at. And then also there's a JavaScript user interface. All right, so we're making student essays. Well, we're making students to fill into our database. So basically what I have to create the students, we've got all the different degree types. It's pretty simple. There's only 8 degrees that a student can be.
Can you quickly just increase the font a little bit?
Yeah, is that okay? Okay, and then you've got all the states that are optional. You've got whether the student is male or female, whether the student plays sports, and the sports are different by gender. You've got their race. You've got just all of the attributes, their SAT score, and they're intended. This code makes them representative to the best degree that I could of actual student data. So you'll see like the SAT, for example, is normally distributed using NumPy there around 1,000. Every 100-point increase or decrease is a standard deviation away. This is the races of all the students are based on real race data. So like 60% of kids are white going into college. So that's in there. So basically this is just going to create a lot of students for us. So we'll just give it a run and look at how this script works. And we'll see some sample output data in just a sec. All right, so you can see it's generated, and the names are all coming from the US Census. So David Cantu, he's male, he's got an 1120 on his SAT, 21 ACT. Also creating the GPAs, their major there, he's Hispanic. He's 59 years old, that's pretty crazy because most of the students generated have age between 18 and 24, and only 200,000 are, yeah, quick question?
Just want to understand, you're getting this data you said from the US Census?
Just the names.
Okay, is this just kind of fictitious data set and you're using the census to get names, or are these actual?
They're actual names.
But I mean, are these people who are actually applying to college?
No.
Okay. So this is just kind of a fictitious data set.
Yeah.
Even though they're actual names.
Yeah, exactly. So then, now that we've got all of our students' data, the last piece of a student's application, I mean, we're oversimplifying here, but is an essay. And the essay gets pretty complicated pretty quick. So to make the essays, we used something called the Markov chain. And we'll go over an example of how to generate some essays. I pretty much just took someone's GitHub essay writer set, and we'll take a look. So how the Markov chain works, it takes 2 previous words as input for predicting what the next word should be based on a given data set. So the given data set that we're working here with is data right here. And this is just 35 college admissions essays. They're all really good, but it's just going to make what it believes to be essays. They're not super great, but we'll just run it real quick. And then what it's going to do is attach all of these essays, and you can read over one of these essays real quick, saying it is the right thing. I think that ambidexterity means more than just school, but are pleasantly surprised to see me dancing around as risky business Tom Cruise for Halloween. I mean, it sort of sounds like a sentence. Sort of counts. It's not terrible, but this is what we're going to use for the essays. And it was pretty difficult to get to that point. And also what we wanted to do was upload all of those to a nice backend database. So I automated that process because the way Firebase is designed is they want you to one at a time. Like if you want to add a student, you click add document, and then you add each of these fields here. And that takes way too long. So that process was automated with Python a little bit. And there's another approach. So besides that, we've got this upload student. So in the case that an institution wants to upload their students on their own that are different than my base set of students, you've got a pretty easy way here to do that using this submission box, just following that comma separated list of values. And we've got thousands of students in here. It looks like we're going to run out, but actually they're just sets of 600 or maybe 500 that I was generating. And then it's just going to repeat. We're back to A's. So we've got a lot of students to work with. And let's go back to the presentation. So now the last step is how the website is working now that we've got our base of students. So what we've got is it's hosted on this senior project admit.web.app. And what you can do is you can toggle through what's important to you in your class. So this is the SAT slider. So if you think you want your class to be around roughly 1200 SAT, and you can rank the priorities of the of each of the sliders. So 9 is the most important. So we've got toggles for every one of the attributes, gender, age, location, and race, student athletes, the major. So obviously you can see this isn't very, I guess, useful, because if you're wanting to toggle specifically gender, age, location, and race, ideally you'd want to give some like sub filters there about which skewness you want. Like if you want it to be a mostly girls school, then you could throw that in there. And we have that for major. If you want it skewed, then you've got skewed for each of the majors. And then, sorry, I didn't mean to do that. And then you've also, so those are the hard attributes. And then you've got the essay features. So what we're trying to do with those essays is predict basically the Myers-Briggs of what each student is. So whether they're extroverted or introverted, sensing or intuitive, thinking or feeling, judging or perceiving, based on the essay. And how that is working, actually that's not working on the website, but how I do have an example of how it works in general. So we're using NLTK, and there's lots of approaches to doing this. I have someone else's approach, I think right here, predicting Myers-Briggs. But that's a little bit more complicated, and I didn't get to do that, although it predicts a lot better. What we're doing is we're using the essays. What we're doing is we're counting the most common words in each essay. We'll just run this here. So the most common words in each of the essays, we're going to see in a sec what they are. All right, so we've got the most common word in this is furthermore. Okay, this is not a good example, but world. Okay, so this person used world 6 times in their essay. So how extroverted is the word world, and how we're computing that is we're getting a cloud of all of the words. Well, a lot of the words, not all of them have it. Furthermore didn't have it. That's why I said it's a bad example. But it's called WordNet, and each word has a set of synonyms that are attached to it. And then how far away the synonyms are from the word you're trying to get to determines how close the word is to the words. And the words we're using for extrovert and introvert are one and team. And that's because they've got a lot of synonyms. And one is like alone, introvert, team is like a group, extroverted. So it's not the best approach right now. But you can see you've got like school is apparently 66 introverted or extroverted and 0.25. So it's more extroverted. But some words are more introverted sometimes. And then in the case that they don't have it, it just says none like that. And not all the essays are all that long. Sometimes they generate them pretty slowly, or like not slowly, just small essays. So you don't get that much out of it. All right, so that's how the text analysis would work if it was working. But unfortunately, this simulation is not the best working right now. We can do a little demo of SAT. SAT works pretty well. So if we want 1100, and we want that to be the most important. And then class size also works fine. The other ones are unfortunately not implemented right now. But if you want like 361 students with average SAT around 1100, then it's just going to build you this class of who you should admit. So right now it's not displaying the essay because a lot of the essays are way too long and it wouldn't show up all that well. But that's just pretty much how that works. Okay. So the work that I would still like to be done in the future, I would like for the simulation to be working in all capacities. I would like all the essay analysis functionality to be implemented. And ideally, I would like to use the approach of the other project. They vectorize their essays for the most common words and basically make like a big matrix to see which is the most impactful words and which aren't. And then they also train it on this data set on Kaggle that's 8,600 tweets that are marked as to what personality type they are. So I think it's pretty nice. I would also like to add authentication. That way you could have different institutions putting their data in and logging in separately and not having access to everything. And then I would also like it to look better looking, to be better looking, because that doesn't look all that great. But I mean, it looks okay for now, but definitely lots of work could be done in the future. What are my regrets? I would say there are a lot. I spent a lot of time doing things that didn't end up being implemented. So that's kind of unfortunate, like trying to learn how to do that, vectorization of words. The simulation would work better if I started with a different approach than what I did. I started just by making it all one string and then turning that string into the table at the end. And that is not a good approach. I think you use a different structure, data structure, because a string is just pretty basic on its own. I would like to put a score of how close you match your set of students to what you actually want. I don't know. I had a lot of fun doing the project though, and not too many regrets, I don't think. All right, so that's pretty much it. Any questions?
That's great.
Thank you.
So just to follow up on your, I think not regrets, but your things to do in the future, like for the essay part, for the matching the actual words. I mean, let's go to the first step, the essay generation step. I think itself is a very gigantic topic in research right now. It's called the text generation, and Markov chain is just one of the research solutions people came up with in the not very latest years, but maybe like it's 4 to 5 years old now. So most modern approaches are like using RNN, like recurrent neural networks. It's very good stuff to generate text. And also I see people are using another architecture called transformer. It's based off of RNN, but there's attention mechanism incorporated into that. But that's all the latest things you can try. In addition to Markov chain. So I think those text you generate is very interesting. When we read it, reads like something, but yeah, but you look at the contents, it's not making a whole lot of sense.
Yeah.
That might be one of the things when you do the introvert extrovert detection, it may not give you the best score out of it.
Yeah.
So that's one thing you could definitely try later on, just to further your project. And then also on the extrovert, introvert, I really like your idea. So so what most people are doing right now is they use something called transfer learning. Like you first train your model based off of some other data sets, like the Twitter data set you were mentioning about. And then once they have a general idea of which word means what, then you can transfer that model to your own data set, like this one. So then you apply the generated assay on top of that existing model to further refine it to be applicable to your own applications. So yeah, that's just my input to that. But I think overall that's a very good project, and for an undergrad student, I think that's a lot of things you have done.
Thank you. Thank you. That's good advice.
I'm just trying to make sure I understand what you're doing with this project. I'm going to ask a few questions here. So you have a list of words that have been rated as far as them being introvert or extrovert words.
Well, it's like, so the way WordNet works is you've got the word, say extrovert. I was using the words one and team, but you've got the word one, and then it's got a synonym set of all the words that are similar to it. And then you can trace a line to all the synonyms of the synonyms, and eventually you'll get to that word that you're matching up against. And how many links away it is the score.
Yeah, okay. But that's the score of introversion versus extroversion.
Yeah, or it's proximity to the word. And then I'm doing it for both extroversion and introversion and comparing.
Okay. But then you're using that to go through an essay and rate the essay?
Yeah.
And come up with a score on the essay?
Yeah.
And that score tells you what about the essay?
If they're an extroverted person or an introverted person.
That's what I thought. I'm just making
Yeah.
sure I understand that.
And not just for introvert and extrovert.
Yeah.
Right? On your website, you can show that later on, but
Okay.
there's a whole scale of
Yeah.
You have other attributes.
Yeah, the Myers, it's based on the Myers-Briggs, which is like what psychologists have tried to do to pin down like every human personpersonality type. So it's this just
Myers-Briggs are a bunch of quacks. No, I'm not real familiar with Myers-Briggs other than to have heard what it is.
Yeah.
Heard the names and know a little teeny bit about it. Okay.
And one thing that I think I learned from you actually is the use of the Firebase, right?
Yeah.
Is that like so it's more like a database to me, hosted on the cloud?
Yeah.
Okay.
Okay. So Firebase is just another database system.
Yeah. They're owned by Google. They have like pretty high limits before they charge you. And they're pretty easy to use. Yeah. Yeah. They've got a really good free tier. I'll show you.
So you have to take your database and you store it in a Google Cloud someplace in order to use Firebase.
Yeah. Yeah. So they let you have like 50,000 reads for free.
Do you actually have to use your own Google account, and then that link also links to your Google Drive, something like that?
I'm not sure about the
isolated
drive.
service?
It would make sense because they're pretty well integrated, but
Okay.
I don't know about it.
Okay.
I think they're great. They've got a lot of documentation, a lot of good videos online about how to use them.
And also, I think just to make it easier for the users, you mentioned about creating account management systems. That's definitely one thing you have to do if you really want to publish this as a public service. And also, like maybe you can break down the web UI into different sections or different pages. Like you have step one, you give some hints, like now you want to choose your SAT score range.
Yeah.
And then give a priority. And then step two is to personalize your criteria. And then step three is like the introvert, extrovert, something like that.
Yeah.
So yeah, just breaking it down into different sections or pages would make it much more easier for the users to understand, I think.
Yeah.
So yeah, UI part, I think, this looks to me like a company project rather than individual project. Like everything you have done has, I think at least that's like a proof of work right now. So
Yeah. Hopefully, maybe. I don't know.
Yeah.
Yeah. Thank you.
All right.
I'm happy.
Yeah. I'm happy. All right. So yeah, then let's just give Rob a round of applause.
Thank you.
Congratulations. Good research.
Hear the crowds roar.